What two songs would you add?
Two songs.
Two songs. I said. Late 60s till now.
From my home borough, the Bronx. I got to put in...
What?
This is StarTalk. Neil deGrasse Tyson here, your personal astrophysicist. And today, we're doing a Cosmic Queries edition. And you know I need Chuck Nice for that.
Yes.
All right, Chuck.
We got them right here. They're burning up the iPad.
All right. They're all from our Patreon supporters.
Absolutely.
We used to do this just for whoever had a question,
Anybody.
no matter what. Well, this is just potpourri, right?
That's it.
All right. So we don't have a third guest with an expertise.
No, this is just the galactic gumbo.
So this presumes I know these
right.
answers.
And, right. Well, I think the true presumption is that you will answer.
Okay.
Doesn't necessarily mean that you know, but there will be an
I'll
answer.
go somewhere where there's an answer that I know.
Exactly.
And we're doing this from my office here at the Hayden Planetarium.
Yes, the Cosmic Crib.
At the American Museum of Natural History right here in New York City.
Yes.
All right. All right, let's do it. Let's start.
All right. First up, Yes King. And Yes King says, hello, Dr. Tyson, Lord Nice. Yes King of Queens here in New York. If we ever get to move to Mars, will we be stronger and faster because we're accustomed to Earth's gravity, like John Carter of Mars? So are we stronger on Mars? There's the real question.
Yeah.
When we get there.
That's an odd question to answer. Because
Okay.
the question is, are you stronger than what?
Right.
Okay. If two of y'all go from Earth to Mars, whatever your strength ratio was here on Earth,
It's going to be that
it's
on
going to
Mars.
be that on Mars. If somebody can kick your ass on Earth,
Right.
they're going to kick
You're just getting a Martian ass whooping.
I'm just saying, in terms of strength. So we have to be precise about how we're going to answer that.
Right.
Okay.
How much stronger will I be as an individual once I land on Mars?
All right. So we got to benchmark it. So let's say on Earth, you can lift 100 pounds.
Okay.
Okay. We have to ask, what does that 100 pounds weigh on Mars? Weighs 40 pounds.
Right.
So on Mars, you can lift more than your 100 pounds.
Right.
Because it doesn't weigh as much, not because you're stronger.
Exactly. Yeah.
I'm just am I clear about that?
Oh, absolutely. Yeah. So I'm getting that 220 pounds that I'm lifting, but it doesn't make a difference because it's really still 100 pounds.
Well, on Earth,
On
it's
Earth.
100 pounds.
Right. It's still 100
So
pounds.
you are not actually stronger
Right.
if everything you're lifting weighs less.
But the stuff that I bring from Earth to Mars,
Yeah.
which probably won't be a lot because the truth of the matter is you're going to print everything that
Ideally,
you're
it's
going to
called
print.
in situ resource utilization.
Ooh, I love it.
ISRU.
ISRU.
Yeah, it's a whole branch of NASA.
In situ resource utilization.
In situ, getting all Latin on you
Yes,
there. Okay.
exactly.
So they don't
In
want
the situation.
they don't want to have to carry everything.
Right.
Because that's very costly for the payload of any rocket.
Right.
We did a rocket equation explainer one time.
Yes, we did.
How quickly you need more and more and more fuel to carry the fuel that you haven't burned yet
Exactly.
to carry the excess payload that you're trying to take.
Right.
So if that's what it is, then you would be 3D printing it on Mars. Using raw materials there.
Absolutely.
Yeah.
So now, let's just say I need an object, and here on Earth it weighs 200 pounds, and there on Mars, when I print it, it's going to be the same, like 200 pounds, but it won't be. It'll be Martian, much less.
Well, it'll be Martian weight.
It'll be Martian weight.
80 pounds.
80 pounds. And
Okay.
so I'm going to be able
80,
to...
I can do that right?
Yeah, 80 pounds, because 100 is 40. So it's going to be 80 pounds on Mars, and... So really, it doesn't make a difference.
That's my point. That's why the question...
It just doesn't make a difference.
No. So here's something that matters.
Okay.
If you're going to build something...
Right.
Structurally, it doesn't weigh as much on the supports.
Okay.
So you can build
bigger, stronger structures.
Bigger structures in lower gravity than you can here on Earth.
Cool.
Yeah.
All right.
And anytime gravity is less, you can do more.
Right.
So look what our mammal branch of the tree of life has done when we entered the water. When we entered the water, but how much do you weigh in water?
I don't know.
Zero.
Nothing.
You're neutrally buoyant.
Right.
You'll slowly sink or you'll slowly float.
Right.
But basically, because humans, depending how much fat to muscle density you have,
Oh,
okay?
let's not talk about that.
Okay.
Please.
But some will sink and some will float. So
Right.
on average, we have the same density of water as we are of water. So in water, we don't weigh anything. Okay? Put a scale in water and stand on it and read it. Okay? That's what I'm saying.
Okay.
So when you don't weigh anything, then structurally, you're not putting yourself at risk. And that's why the largest creature there ever was is a mammal, and it lives in the ocean.
Right.
It's a whale,
Right.
the blue whale.
That's it.
We got one of those hanging
In the museum.
In the museum.
Yes.
Okay.
And by the way, it says all the time, my back is killing me
It's
because there is no water here.
held up.
These hooks. I can't believe the gravity that I'm feeling right now.
So when they say how much does a whale weigh,
Right.
the answer is 0. They give you a weight, and how do they give you a weight? They take it out of the water,
Right.
put it on a scale on dry land,
Right.
and then it weighs gazillion tons. But that's not the weight that the whale feels as it moves through the ocean.
There you go.
Now, there's another side of this, not to just make a long answer longer, but your weight is whatever is the attraction of gravity is to you, okay? Your mass doesn't change.
Doesn't change. Right.
Doesn't change,
Right.
okay? Mass is, count up the molecules in your hand,
Right.
your body,
Right.
and the rock. The mass is the mass. The measurement of a mass is the same no matter where it is in the universe,
Okay.
okay?
Nice. All right.
Wait, unless it's moving relativistic speeds, then the mass increases. But holding that aside,
Right.
that's a different conversation.
Okay.
Okay, but mass matters with regard to momentum.
Right.
Okay, so watch. If I take a 100-pound brick and I throw it at you,
I'm suing you.
it'll knock you over.
Yes, it will.
Okay. Now, so how much mass is in the 100-pound brick? We can ask.
Right.
Okay, you can measure up that mass. If I pick up that brick on Mars, it only weighs 40 pounds. But if I throw it at you,
The mass is the same.
the mass is the same.
Right.
It'll knock you over in exactly the same way it would have done it here on Earth.
Right.
Just-
Okay.
Just so you know.
And in both cases, I'm like, why you hit me with a brick?
Sorry, that was a morbid example.
happened?
I know. There probably
did I
some other example I could have thought of. I'm sorry. Sorry about that. All right. Next question.
All right. This is Alicia Okoroafu. This is Alicia.
Okay. Hi, Alicia.
Hey, Alicia. What's happening? How you doing?
Alicia O.
Alicia O.
Yeah, okay.
There you go. If the Earth center wasn't hot and there was a hole all the way through, what would happen if you jumped in? Because you will only fall down until the center of the Earth, and then you'll start going up and you'll start falling backwards. Oh, by the way, my name is Arian, age 11, and I'm from United Kingdom, Wales. Okay.
Wait, so what was the first name? That's just a handle?
I guess that's mom or whoever who sent it.
Okay.
Right.
Okay.
But Arian, who actually...
Arian. Hi, Arian.
Who
Okay.
spelled her name, Arian. Arian spelled her name
You don't know if it's a boy
phonetically.
or a girl.
Oh, who knows?
Okay.
Spelled her name. Oh, I don't. Okay. Arian, who spelled their name, their name phonetically, is 11 years old from Wales.
Don't be so genderized, dude.
Yeah,
Okay.
that's true. That is true. So this is what Arian wants to know. What happens when you jump in a hole that goes all the way through the center of the Earth?
Oh, yeah. So I'd like the fact that Arian turned off the heat first.
Isn't that something?
That's good. Very
Arian knew the
thoughtful.
deal. She was just like, we have a molten core.
Yeah.
So at the center, here's what happens.
Right.
Yeah.
You got. So,
Crackle, sizzle.
yeah, the core is hot enough to vaporize you, so you would not make it to the other side, just so you know. But if you dug a hole through, and I did this, I mean, I didn't do it. I did the math on it. Well, when I was a kid, maybe when I was 11, I said, if you dug a hole from the United States, because
Right.
that's where I lived,
Right.
where would you come out on the other side? And everyone says, if you dig a hole all the way to China.
Right. That's
Okay.
always the case.
That's how
You
we
dig
say
a
it
hole to China.
here in the United States.
That's right.
However, China is not where you will land if you dig a hole through the center of the Earth. Because if you dig a hole through the center and you start in the northern hemisphere, you have to end up in the
southern hemisphere.
In the southern hemisphere.
Right.
If you start in the western hemisphere, you got to end up in the
eastern hemisphere.
That's how the geometry works.
Exactly, because it's a ball.
It's a ball.
Right.
All right. So when I did that and did the measurements on that, if you dug that hole from the United States, you would end up in the Indian Ocean.
Nice.
Okay.
So basically,
the South Indian Ocean.
You just flood the United States.
Yeah,
that's really what you
through.
did. You pop through, and all of a sudden you're like, "Oh Lord, what have I done? What have I done?" And the whole United States is now flooded.
So we have to ask now, where, if you live in Wales,
right,
where does their hole come out? Well, it's easy to figure that out. It's trivial, okay? Because what line goes through the United Kingdom?
It's
the most famous line, the prime meridian, most famous line in the world. And what is diametrically opposite the prime meridian?
The equator. What?
Let's try that again. What's diametrically opposite the prime meridian?
Oh, give me a second. I'm trying to think of the line that goes across the North Pole.
And down on the other side.
On the other side.
It goes all the way through.
The South Pole.
No, okay. Okay, I'll help you.
Oh, the prime meridian.
No, the prime meridian is only pole to pole, but on the other side we call it what? It's the same line continue, but we have a different word for it on the other side.
Oh, I don't know.
The international date line.
Oh, I didn't know that.
You didn't know that?
I did not.
You didn't know that?
I didn't know that the prime meridian and the international date line were the same line.
They're the same damn line.
I did not know that.
You didn't know that?
I have never made that connection. Because people always talk about the international date line.
In its own world.
In its own
way.
world.
Okay.
And then they talk about the prime meridian because it's like, oh, this is the line that runs all the way through. So I didn't know that.
Okay.
Okay, cool. Okay.
Right.
So that's why
when I was a kid, I spent a lot of time looking at maps and globes and stuff. I thought that was just cool. Sorry. But just to be clear, I was bigger than other kids. So
Thank God.
That kind of nerd activity.
Let me just tell you something.
Get your ass whooping.
I'm just going to say.
Up in the Bronx.
Yes.
But
you're a man of large stature. If you were Chuck Nice size, the world would not have Neil deGrasse Tyson. That's all there is to it. Because if Chuck Nice was a kid and was just like, did you know that the international date line and the prime meridian were actually the same line? Isn't that amazing? First of all, they'd have been like, take off all those clothes, the shoes, give me the money, and then they'd have beat me.
They'd take your lunch money.
Money, sneakers, and then the beating. That's how it goes. Money, sneakers, beating.
In that order.
In that order.
So what's convenient about the international date line, because that goes through Greenwich, England,
right?
All right, is on the other side is the middle of the freaking Pacific Ocean.
Right.
So you don't want the international date line going right in the middle of your country.
Right.
Because then one half the country would be one day, the other half would be the other day, 24 hours different, right?
Exactly.
And so you don't want that. So it's just convenient. Now, there's few places, is it the Solomon Islands? There's some place where they have to do some bending.
Right.
Because there's some scattered islands in the Pacific.
Right.
But basically, it bypassed that challenge.
Right.
Okay? Just I'd say that. All right.
Okay.
So Arian will dig a hole and will land in the South Pacific.
Okay.
Okay. Let's get back to the question.
What's going to happen when you jump in it?
Yeah, so you jump in, you will fall and accelerate. Continually.
Right. You're picking up speed the whole time.
Actually, it's not discrete, so I have to say you will fall and accelerate continuously.
Right.
The difference between continual and continuous. I was talking to a Brit who invented the language, so we got to be good about the language here.
Yeah.
Okay.
That's right. Yes, they sound so much smarter than we do when they speak English. Well, some of them.
And we're self-aware. Right. You don't go deep Cockney.
Right. Yeah. We sound smart if they're going like, "Hello, governor," and all. Yeah. Then we sound like the smart ones. But if you're like Gary, our Gary O'Reilly, automatically sounds sophisticated and smart with a British accent.
Right. Yeah. So you'll jump in, you'll accelerate continually.
Right.
Until you get to the center. Let me just, for those who didn't know, okay, a river flows by continuously.
Right.
The parade floats moved by continually.
Right.
Right, because those are discrete
They're discrete and they are not connected.
They're not connected.
But if it's connected, then it's continuous.
And usually it's the same material substance.
Correct.
Right.
Okay.
You can't tie a chain between the floats and call it continuous.
Right. Exactly.
No. So you jump in, you will accelerate until you get to the center, where you'll hit peak speed.
Nice.
Peak speed. And I'm thinking that speed is 5 miles per second.
Okay.
I have to verify that. I'm just pulling that out.
5 miles per second. So you're dead.
No. You're just falling.
Yeah.
You are weightless.
Right.
You don't care that you move 5 miles per second. What do you care?
That is true.
You're on Earth going 20 miles per second around the sun.
So now, okay, I'm going to let you finish because
Your speed, you don't care what this.
No, I was
when
talking
you're
about
in an airplane.
when you said peak speed. That means now we're going up because you're.
I didn't get there yet. We're in the center of the Earth.
All right.
Okay.
That's what I'm saying.
Peak speed, center of the Earth. Now, what happens to you? The hole is all the way through the Earth. You will overshoot the middle.
Okay.
Right. You're going 5 miles per second. You'll overshoot.
Right.
You'll overshoot the middle, and now Earth will slowly slow you down.
So that's what I was saying. You're dead. So that breaking, actually, you're going up now.
You're not going up. Up is anyway away from the center of the Earth.
Exactly.
Right, okay.
So you're going up in terms of.
Now you're going up into and towards the South Pacific if you're in Wales.
Right.
Okay. And you're slowing down continuously.
Right.
And in the exact rate that you had sped up going in. So it's the exact undoing of everything that happened en route to the center of the Earth.
Sweet.
So then you will we're ignoring air resistance here, of course.
Okay.
Okay.
There we go.
And then you get to the South Pacific. Now, assuming the water's not just flowing in against you.
We have a tube that takes us above.
We'll give you a life-saving tube.
Right.
You'll come right up to the edge, and unless somebody grabs you, you're going to fall back down, and you're going to repeat this forever.
Oh, that's terrible.
Somebody's got to grab you.
Oh, this is a good version of hell.
Forever.
I like it as a version of hell.
Yeah, you'll just keep going back and forth.
Right. Like,
there it is.
Oh, well, that was cool.
And one round trip,
right,
it comes back to Wales. One round trip takes the same amount of time as an orbiting spacecraft.
Ooh.
Yep.
That makes sense.
So if the space station orbits over your head, and you jump in the hole, you go down the other side. You actually see it passing over
the space
on the other side.
That's great.
And you come back, and then there it is.
There it is again. That's really cool.
It's really cool.
Yeah, because you're going the diameter of the Earth.
Well, you have to do the math and the Newtonian physics, and it all works out.
Yeah, it makes sense though because you're falling, it's falling.
Yes.
So you're falling the diameter, it's falling the circumference.
You're both in free fall.
That's awesome.
In Earth.
Dude, I love it.
It's physics.
That's really cool.
Yeah, that's cool.
Well, Ariana, thank you for that. Ariane, sorry. You're right.
Yes.
I messed up her name and she spelled it phonetically.
If it's a she.
Sorry,
Damn,
Ariane.
Chuck.
Sorry.
They.
There you go.
Thank you, Ariane.
Thank
for
you,
that question.
Ariane. Okay.
From Wales. Great to have fans in Wales.
There you go. All right, here we go. Brett S. Chapel says, hello, Dr. Tyson and his niceness. Warm greetings from Copenhagen here in Denmark. Wow, we're getting international.
No.
Look at this.
By the way, one of the most famous astronomers ever was Danish.
Okay. Give me
And I sat for 20 minutes with some native Danes to teach me how to pronounce his name.
Okay.
And I will show off now that I can pronounce his name.
Okay, who is this?
Tycho Brahe.
Tycho Brahe. No idea.
Tycho Brahe, we call him.
Oh,
here.
Tycho Brahe.
Tycho.
Okay.
There's a crater on the moon named after him called Tycho.
Tycho.
It's the crater that has rays coming off of it.
Nice.
Yeah, it's called the ray crater Tycho. Very famous crater. But Tycho Brahe.
Tycho Brahe.
Yeah, I want A+ for that because I worked my butt off pronouncing that.
Pretty cool.
Okay, what do you have?
All right. Carl Sagan edited a golden record, which went into space in 1977 on NASA's Voyager expedition. This disc included music by diverse sources such as Chuck Berry, Peruvian panpipes, and Johannes Bach. If you had to revamp the playlist to meet 2024 standards, which one of the two songs would you add to ensure a more modern repertoire?
Oh.
So is there a song recently? So let's get past Chuck Berry time. So I'm going to say you have to go from late 60s till now. What two songs would you add?
Two songs.
Two songs. I said. From late 60s till now. Because Chuck Berry's the 50s.
Okay.
So you got to go late 60s till now.
I got to put in Rapper's Delight.
What? Well, it did start it all.
It birthed
an entire genre.
It's from my home borough, the Bronx.
That's true.
Okay. Bronx birthed hip-hop.
There you go.
So I put in Rapper's Delight.
Wow.
Okay.
Worst rap song ever made. But the most important rap song
and it charted.
ever made.
It was #1.
Yes, it did.
And we danced our ass off in college
This
to
is
that
true.
because when
Okay.
it came out when I was in college.
All right.
And shake it off. Shake it off.
Wait. Oh, Taylor Swift. Shake it off.
I don't know. I mean, we got to update it.
Right.
And that's very in the moment.
Right. Whatever alien finds this will also find the leader of our world.
That is the leader.
When they listen to Taylor Swift, they'll be like, oh, and this is the leader of their world.
Take me to your leader? That's the leader.
There she is.
From the realm of pop music, I think that's what I would pull out.
All right.
What would be fun if we put John Cage's 427 or whatever the name of his work is? You know, it's a piano work.
Oh, okay.
You know it?
I don't think I know that.
The pianist sits there at the piano and doesn't do
Is
anything.
this the guy who doesn't play?
Doesn't do anything for 4 minutes.
Okay,
Right.
I've heard about this. Yeah.
We should put that on the record.
Yeah, that'd be great. 4 minutes of silence and somebody going.
And the aliens are
Someone
listening.
clearing their throat.
It's like, what's wrong with these people?
Right.
It's there. So maybe if I were to do it, maybe that. I might have thrown in a disco song, but disco kind of came and left.
Yeah.
And I would not have predicted that at the time.
Right.
I would have said hip hop was a flash in the pan and disco would be here forever.
No,
but the opposite has
opposite
happened.
happened.
Yeah.
Yeah.
What 2 songs did you pick?
Okay, for me, I'm going to go Kendrick Lamar, They Not Like Us. Yeah.
Ooh.
Just because clearly these are aliens that found it. So
Oh, okay. Very clever. Very
right,
clever. Okay,
right.
all right.
And for my second song, Smells Like Teen Spirit, and that is Nirvana. And the reason is because I don't know any teenager ever, no matter what their color, no matter what their creed, no matter like what their background, who doesn't hear that song and isn't moved by it. They truly capture teenage angst in a song.
They found the resonant frequency
Way to say it.
of not just of a generation, but of
Of a period of life.
life.
Yeah, a period of life. Everybody knows what it is to have the anxiety of teenage existence,
okay.
and it exists in that song.
All right.
So yeah, it smells like Teen Spirit. Yeah.
All right.
Yeah.
All right.
So
I
there
love
you
that.
go.
Okay, we hope that. There you go.
All right. Well, there you go. This is Oliver Cook. Hello there. This is Oliver. I'm a 36-year-old painter and decorator from South Wales.
Whoa.
Love the podcast.
This is a second
This
question
is another
from Wales.
second from Wales. I want to know if there's such a thing as absolute stillness in the universe. And if so, what would happen if we were to reach it? Would everything else just blink out of existence? Wow, look at that.
That'd be a fun science fiction premise.
That would be.
Or if you can't find it, you create it.
Right.
Right? Earth is rotating. Let's stop the rotation.
Right.
Earth is going around the sun. Let's stop that. Or the sun is going around the galaxy. Let's stop that.
Right.
Galaxies falling towards it. Let's stop
The
that.
power of stillness. What a cool super. I have the power. And now, would that be stillness all the way down to the vibration of molecules and atoms?
That's not how I'm thinking of the question.
Okay.
But it turns out that that's not possible because quantum physics demands that even when you cool something down
Right.
to absolute zero,
Absolute zero.
in the day,
Right.
in Lord Kelvin's day,
Right.
uh,
Oh, dear. Lady and Lord Kelvin.
Kelvin, his actual name was Thompson, but Kelvin, when he became Lord, he was Lord Kelvin.
Right.
A brilliant physicist, a little cocky, but brilliant. He pioneered the Kelvin temperature scale,
Right.
which is the absolute temperature
zero.
scale.
Right. That's
So what they found was, at any given temperature, air molecules are vibrating.
Right.
Or they're moving among and bouncing off each other.
Okay.
If you drop the temperature, they move a little slower.
Right.
Drop it some more, they move a little slower.
Nice.
And so he extrapolates it. There must be a point where they stop moving at all.
Okay.
If they stop moving at all, there's no temperature left. Absolute zero.
Nice.
You can't have temperature less than the temperature of something not moving.
Ooh.
Completely reasonable before quantum physics.
Aha.
Quantum physics says you try to take it to the lowest possible energy state, and you cannot characterize a zero energy state. There's always some fluctuation.
Something is moving.
Fluctuating.
Or fluctuating or
I
doing
want to distinguish sort of vibration from translational movement.
Exactly.
And I'm thinking he means translational movement. Is there a point where nothing is moving?
Right.
Okay? So, the answer is no.
Wow.
Because you've been on a train before.
So true.
let's say Amtrak, not everyone has, but Europe, they're all about trains.
Right.
Here, some of us have been on trains.
Yeah, we only have one. It's called Amtrak.
Yeah. And you sit on the train and you look out the window, and all of a sudden, things start moving.
Right.
You're at the station.
Right.
And you're there,
Right.
and then things start moving backwards.
Right.
And you rationally say, oh, they're not actually moving. I'm moving because I'm on the train.
Right.
But you didn't know that because it was so smooth.
Right.
Okay? All I'm saying is, if you believe you are stationary, someone else has equal rights to that claim. And if you say they're in motion, they can legitimately say, no, I'm stationary and you're in motion. There's no experiment you can conduct to say otherwise.
I know I am, but what about you?
Well, you are, but what about you?
I know you are. But what am I?
I know I am, but what are you? So that is a foundational principle of relativity.
Right. Yeah.
Okay? And so we're stuck with it. That's how the universe is put together. There was a brief moment where, looking out to the cosmic microwave background,
Right.
the question was, is it a different temperature in this direction than that direction?
Okay.
Because if it is,
Right.
that means we can tell absolutely that we are moving relative to a reference frame that's the entire freaking universe.
Right.
There is no such thing as no motion.
There's no such thing as no motion.
Correct.
Because once you get down to the quantum, there's something.
And even so, even if you think you're in motion,
Someone else's frame of reference.
it's a reference frame.
Someone else's frame of reference
Even
says
if you think you're not
they're
moving.
in motion. Your frame of reference says I'm in motion. You're still.
Correct.
There you go.
And there's no experiment that you can conduct that can tell you differently.
Right.
Okay?
Wow. I never thought we would get all of that out of Oliver's
there it
question.
is.
That is fantastic.
What's his name?
Thanks.
Oliver Stone? What was his name?
Oliver Cook.
Oh, Oliver Cook. Oliver
Yes.
Stone's the director.
Yeah. I'm Oliver Cook.
Okay.
Please, sir, may I paint some more?
That's a bad Welsh accent.
It certainly is.
You're imitating Oliver
I know,
from the streets of London.
Yes, exactly. All right, here it is. Caleb Carter says, howdy from northern Indiana. I just watched an episode where someone asked if a pair of quarks get spaghettified, would they sooner or later find an equilibrium? Y'all responded with essentially, I don't know. But I do know. This is the moment there is enough energy to sufficiently separate them. They would just make quarks to become a pair again. Thus, an infinite amount of quarks would be made. I remember y'all talking about how a single H2O molecule doesn't make water, but water is made from clumps of H2O. It's possible that quarks and gravity are related in a similar way. If, and this is a mighty big if, both cases are true. Could this explain why black holes are infinitely dense? Could this just be another version of a runaway thermonuclear reaction like we see in stars, but in terms of gravity? I'm going to handle this one for you, Neil.
You got this?
I
Okay,
got this
thank you.
one for
Thank you. Because
Here we go. Watch this. Nah, bro. Sorry, bro. Nah. That's not how it works. That ain't how it goes.
So I'm thinking again about this quark falling into the
black hole, which
would it
where
just,
we were talking
would
about.
Would you have a runaway creation of quarks? And I realized, where's it getting its energy from? It's getting its energy from the gravitational field of the black hole.
Correct. Right.
So the black hole, I think, would eat itself.
It's right.
Its entire gravitational field would morph into particles.
Right. Because it's feeding
off
that
of the
reaction, which is feeding off of the field.
Right. But then the particle itself can then make a field.
Exactly. So you have this kind of just infinite loop that would keep happening, and it could end up eating itself.
Yeah, so
that's really cool.
Now I'm no less than what I knew before.
Exactly, right.
So I don't have a good answer. Yeah. I don't know how to respond.
Right.
It remains a mystery, at least to me, if not to others.
Okay.
Out there.
There you go. Mm-hmm. That was easy.
So is he saying that the gathering of quarks is itself the black hole in the way the gathering, because you can't have a single black hole molecule in a sense.
Exactly.
Right. So, but a bunch of water molecules makes water. Right. A bunch of quarks makes a black hole.
Yeah. Nah, bro. It's fun to think about.
But you did give it quite a dramatic read, that question. That was
exactly.
all right. Time for just a couple more questions.
Okay, here we go. Fabio later says, good day, Fabio here from Washington.
Fabio?
Yes, Fabio.
Okay.
And, should I say Fabio? So lovely to see you, dear. Might I say you look ravishing? Excuse me while I stroke my hair and look at you longingly while I flex my pec and wash your clothing on my washboard abs. I am Fabio.
That was his real name, right? That
Yes,
dude
I don't know.
That they drew on all the romance novels?
That was his SAG name. We know that.
Screen Actors Guild.
Screen Actors Guild. That was
Okay.
his name for them. So, All right. He says, in your educated opinion, do you think media censorship should exist in future space colonies in order to mitigate most of humanity's undesirable traits? Wow, bro.
That's a good one.
Wow, look at you.
Yeah, I mean,
He's talking selective, protective
Yeah.
censorship is what he's talking about.
with all of its weaknesses, I think its greatest strengths outweigh them, and that's the strength of freedom of speech.
There you go, my friend.
And
happy.
I say that because I'm indoctrinated as such as an American.
I'll tell you why you say it, because you
There's
live in the
America.
greatest damn country on this face of
Mer-
this earth, America.
America.
That's right.
Apostrophe M.
That's right.
URRICA.
Let me tell you something.
America.
Jesus gave me the right to free speech. That's because I'm here in America. All right? He let all you other people speak too.
Let them
All right, let's go. Because I could do this all day.
No, we need a ref here.
Yeah.
Right? Blow the whistle. So, and maybe because I'm indoctrinated that way, I allow that to be a possibility.
First of all, I agree, but I disagree that it's indoctrination. Here's why I disagree that it's indoctrination. Because with the right to censorship comes a certain power, and we all know that power corrupts.
Yes.
Power also seeks power.
Yes.
And so if you were to give people the ability
never
to
ends well.
censorship, it never ends well. That's
Okay.
all there is to it.
It's not just indoctrination, there's evidence.
There's right. There's empirical.
If you want the stability of that colony to be a thing,
Right.
like with all of the challenges and all the fits and starts
Right.
that free speech
Causes. Right.
the benefits outweigh.
Any of the detriments.
Yeah.
And quite frankly, what you need to do, Fabio, is have free speech and teach everyone in that colony to think critically so that they can assess the value of the free speech that's being spoken.
Ooh, so you get it you nip that in the bud.
That's it.
You start out that way. Maybe
that
you
way.
don't even allow people to go to that colony.
Right.
Unless
they can think critically. And, I'd like to go to the colony. No, dumbass.
No, stop.
No.
Dumb.
You stay your dumbass right here on Earth where you belong.
Stop.
All right.
It's the dumbass disqualification.
Dumbass disqualification. That's it. That's it.
We can formalize this. We should name that planet Rationalia.
Okay.
Okay?
Like in your book.
Which I just happen to have.
Excellent.
So I
Wait,
tweeted.
you got to tell them the name of the book.
Oh, Starry Messenger, Cosmic Perspectives on Civilization.
Sweet.
So I and others came up with this idea of Rationalia at a conference,
Okay.
a science conference.
All right.
And I tweeted it. It says, Earth needs a virtual country. I wasn't thinking other planets.
Right.
Virtual country, Rationalia, with a one-line constitution. All policy shall be based on the weight of evidence.
Whoa. There you go. Boom. That's it.
That's it.
That's it. You get rid of so many problems that way.
So many problems.
So
and if
many
you don't have
problems.
evidence, then there's no policy.
Yeah, exactly. But wait a minute. I feel. Shut up. Shut up. Like, cares about how you feel. You shut up with your feelings. Get out of here. We said evidence.
No, wait, hold on. Wait, just to be clear.
Go ahead.
On Rationalia, you can have feelings.
No, your feelings are fine, but you can't.
just can't make a law.
Right. You can't write.
You just can't write a
You
law
can't be a part of the conversation.
No, you can have a conversation. You just can't write a law based on your feelings.
No, but that's what I'm saying. When we are debating the law, what the law should be, your feelings don't matter because it's all about evidence.
If it's about evidence, correct.
Right.
Correct.
Yeah.
So on that planet, free speech would be, oh my gosh,
Exactly.
it would be the blooming of the greatest democracy the universe has ever seen.
There you go. Wow.
So that's from the chapter in here called Law and Order.
Law and Order.
Law and Order.
From Starry Messenger. Very kung kung.
It's really what. Thank you for the sound effect. It's things that we care deeply about in civilization. It's what they look like when seen through the lens of science.
Right.
And so many of the arguments that we have over holiday dinners, they evaporate.
Right.
In the presence of rational analysis.
There you go.
So that's what goes on there. Okay.
All right, here we go. Let's do this one. Might be our last one. Hello, Dr. Tyson and Lord Nice and anyone else that might have been invited. Craig Cordwell from the UK here. I was wondering, how sure are we that spiral galaxies like our own and our neighbors, Andromeda, are not being sucked into the black hole, which is what causes the flushing toilet-like shape that makes up the galaxies? Love the show and look forward to hearing the episode.
Ooh, okay. This makes like 4 people from the UK. What is that on this round?
Yeah,
okay.
we got a lot of people, a lot of love from the UK.
A
lot of love from the colonizers. A lot of love from the colonizers on this show. But watch out, we tune in next week. We 2 British dudes sitting here.
There's an old joke about Earth. There's no such thing as gravity. Earth sucks.
Right.
Okay. All right, so black holes are not giant sucking machines.
Right.
They just have a gravitational field.
Gotcha.
If you get really, really close, kiss your ass goodbye.
Right.
If you're not, you'll just maintain an orbit around it.
Like we do the sun.
Like we do the sun. Exactly as we do the sun.
Right. We don't crash into the sun. We're not getting sucked into the sun.
Right. And so if you step back, it looks like all the planets are spiraling around, which they are.
Right.
But they're not getting sucked into the sun. Right. All right. So the toilet bowl effect.
That swirl.
These are called spiral arms. And our understanding of them came of age while I was in graduate school. Because how do you maintain that? And because the inner parts of the galaxy actually will complete an orbit faster than the outer parts. So you get this stretching of these coherent cloud formations, gas form. They're not cloud.
Right.
They're gas clouds,
not puffy clouds.
Not puffy Earth clouds, right? They're gas, streams of gas that, because the galaxy rotates, as we say, differentially, which means the inner parts rotate faster than the outer parts, it will drag it into this spiral shape.
Right.
And one of our big challenges was, how does it maintain the grand design 2-arm spiral without over time just winding up on itself?
Right.
Okay, so that's where it got complicated. And we had to worry about what's called spiral density waves. It's not really a physical gaseous structure. The gas is everywhere. There's a density wave that's moving across the clouds, triggering star formation.
Wow.
So wherever this density wave is, there's star formation in that shape. So it's more complicated than it looks, but all I'm saying is everything is just simply orbiting the center of the galaxy.
Right.
And it's not like a toilet bowl that's ultimately going to go down the tube.
Right. And because there's gravity at the center of the galaxy.
Yeah, there's gravity there, and that's what maintains the orbits.
The orbits.
Right. But if you want it to fall in, you're going to have to stop the motion.
Right.
Then it won't know to go sideways, and it'll just fall straight in.
Straight in.
That's what you'd have to do if you wanted it to actually behave like a toilet bowl. By the way, we detect black holes because of this toilet bowl phenomenon.
Oh.
Okay? If a gas cloud or a star gets too close, tidal forces will rip it apart. The material spirals around, and the spiraling material, because the inner parts are rotating faster than the outer parts, there's friction. And wherever you have friction, you have what?
Heat.
Heat. So this, which we call an accretion disk,
right.
This disk, as it spirals, gets hotter and hotter and hotter and hotter and hotter. It starts glowing. First red hot, then white hot, then blue hot. Then it's glowing so hot, it emits X-rays.
Aha.
That's how hot it gets. And so our greatest discoveries of black holes occurred when we launched X-ray telescopes into orbit.
Right.
Earth orbit. And you look out and you see these sources of X-rays. Those are black holes talking to us in the universe.
Is that the Chandra?
Yeah, Chandrasekhar, a brilliant Indian physicist. We named the telescope after him. In the way we named Hubble after Edwin Hubble.
Right.
So the Chandrasekhar X-ray telescope is named after him. Right.
Cool, man.
But anyway, that's how we found black holes. Very cool.
There you go.
And that is a toilet bowl because it's falling in as it radiates away. Cool. Whereas we are not falling in. It's just a density wave moving across clouds that are already there. All right. That's all the time we have for it.
That was great, man.
We caught a lot of
fun.
Ground there.
Yeah. That's our international version of Cosmic Queries.
There you go. There you go. Plus Northern Indiana. This has been like another installment of StarTalk Cosmic Queries. Galactic Gumbo.
Galactic Gumbo.
Galactic Gumbo. We love those. Those are nice.
Absolutely.
Because we can do that just ourselves.
Exactly.
We don't need bring in the big guns, extra expertise.
We don't need no stinking astrophysicist.
Extra astrophysicist.
Right.
All right. Until next time, keep looking up.